So off we go. Let's have a programming lecture for the day. More Scratch. It'll be fun. I'm going to teach you more about that looping concept that lets you come back around to your previous code. And we're going to make a cute little game at the end. It'll be fun. So yeah, let's go back to loops. So remember, the idea of a loop is you have some code that you would like to repeat. Is this the right size? Cool. All right, so like you want to do thing A, then thing B, then thing C. You know how to do that in Scratch, right? Just put blocks up on top of each other. A, B, then C. And then we also want to just be able to like come back and repeat that a few times and eventually stop, but maybe forever, who knows. So that's kind of how we want the program to look if you make this little flowchart version of it. But in Scratch itself, we have a bunch of different kinds of looping blocks, and they look like this. It's like they're eating a bunch of other blocks. We learned about the repeat block last programming lecture. It was like repeat. Then you put something here like a number n, repeat n times, and then whatever you put in here, it could be millions of lines, millions of blocks itself. It doesn't have to be just one thing you want to repeat. It could be repeating a bunch of things. It'll just keep on going, and it'll do all this stuff n times, maybe 10, whatever you put there. Okay, and this little bit, the stuff that gets repeated, there's a technical term for that. It is called the body of the loop. All right, so the body gets repeated n times. It gets repeated n times. And I don't know, it's maybe you think of it like the loop is the stick figure, and like here's the repetition part, and then the meat, the stuff that you're repeating, is the body of it or something. I don't know. That's how I think of it, at least, but that's what you'll hear a lot. So yeah, let's have some examples of loops. So again, there's a million of them. Let's go to scratch.mit.edu, and it's in that orange section, right? Let's go and find them. Eventually it will load for me. Come on. Oh, this is I'm gonna try refreshing the page. That was weird. Okay, that works. Cool. So yeah, down here in control, you have this repeat block. That's a loop. It's going to repeat the stuff inside a bunch of times. There's other looping blocks. There's a forever block. I think you can imagine what that one's going to do. And you see how like once it finishes the stuff inside, there's like a little arrow telling you to come back to the top. Come back to the top. All right. So yeah, loop is just a special kind of block that you can put blocks inside of the body, and it keeps running that body thing. All right. And you can tell it how many times, or you can make it run potentially forever. So that's a new one. There's a forever looping block. Forever, please. Whatever you put in here just keeps on going until you click the little stop button on Scratch. So that's kind of cool. That's useful. And yeah, just the inside of that block is going to run repeatedly. And each time it runs one section of the body, it goes one time through it. That's called an iteration. We say that loops iterate. It's like fancy Latin root for to go, right? It just goes through the loop once. All right, we call that an iteration of the loop. And then there's one last kind of looping block, and this one is the most powerful. It's called a repeat until block. All right, you can do both of these with a repeat until. This one's the only one you really need. These ones are just to make your life easier as a program. But repeat until, super powerful, and I want to teach that to you today. You see that it takes a pointy thing, and that pointy thing is just like you gave to your if then else, right? So very similar. It's going to take something that could become true or false, and that is going to repeat until that thing becomes true. So let me draw that in my best artist rendition of it. So here's like the repeat until block. Repeat until, and then you give a pointy thing, which is your Boolean condition. All right, it's going to keep on going until this becomes true. There's your condition. It goes right there. And hopefully, if you want it to loop a few times, it'll start out being false, and then whatever you do here, like affects variables in such a way that eventually that condition becomes true, because that's when you would like it to stop. Right? So this will run the body until that condition is true. So it'll keep being false for a while, usually. Repeat until. And I'll give you an example of this. I just want to say the words first until that condition, I'm calling it cond, is true. Okay, so that's how that one works. Let's have a fun example with the forever block, because that's always exciting to just have a program never stop. So let's make a program where the scratch cat just bounces around the screen forever. I don't know, maybe he's in space. There is, you give him his name again, scratch cat. And I don't know, let's put him in space. Why not? Or maybe he's just like made of helium or something. We'll just put him in the spectrum. And so I'm going to use this forever block, and I guess I'll start the program when the green flag gets clicked. I would like to forever do what? All right, I just want the scratch cat to bounce around forever. And so there is a couple blocks that I can use here. So we know that there's a move block, move 10 steps in your current direction. That's a thing. So if I just did that, forever move 10 steps, watch. Then you get stuck on there because you can't like go out of bounds. So that's not as fun. If you like change the scratch cat's initial direction, he'll shoot off that way though. Whee! And then he'll get stuck up there again. Let's bring him back to 0, 0 because I can't even see him anymore. There we go. Any questions about that? So it's just going to run forever until you click stop. It's going to run the body. Just one block right now. Okay? Does that make enough sense so far? So yeah, just move 10 steps. It's like it's clicking this block a bunch of times, and so it's moving multiple steps, but it's producing animation. Yeah, that's kind of how that's working. And then wouldn't it be nice if once he gets to the wall, like he bounces off the wall, there's actually a block for that. Maybe it's in sensing? Either there, maybe in motion. Yeah, here it is. It's called if on edge bounce. So if he's on the edge, boop, you click it, he bounces off the edge. And it's like, as you would expect bouncing to work. Okay? So, oh no, let's set him off that way again. So this is now the body of the loop, right? And this is going to be repeated a bunch of times. It's going to move 10 steps in your current direction. And then this block only fires if he's actually on the edge, though. So usually he's just moving 10 steps each step. But if you're on the edge, he bounces off. And then this just never ends. And then he's just got like he's made of helium today, and he's bouncing around forever. If you want to stop the program, the forever loop doesn't want to stop. You got to click the stop button. Okay? Any questions about how this code's working? It's a fun one, I think. Useful knowledge. If the scratch cat's direction was perfectly left or right or up or down, so back to 90, he's only going to go left or right, right? Because he's just perfectly bouncing off the edge. So that's kind of not as exciting as zooming off that way, maybe. I don't know. But yeah, that's our first example of the day. Okay, so that's a forever loop. Move 10 steps and bounce off the edge if you're on the edge. Just keep doing that forever, please. Okay, so that's our first example of the day. Let's do one that involves variables this time. All right. So let's make a program that sums up all the numbers from 1 to 10, because maybe we don't know what that is, and it's hard to like use a calculator. You can imagine like what if you wanted to sum all the numbers from 1 to 100? That would take forever on a calculator. So we can write a program to do that. All right. We'll use some variables. And I'll prove to you that this is going to involve a loop, okay? So here's kind of the setup. If we want to get this answer as a program, we need a place to hold that answer. So first of all, we're going to need a variable that holds the sum that we're trying to build up, all right? Holds the sum. We're going to like add a bunch of numbers into sum. And so sum should start out then at 0, right? Because if I'm going to add a bunch of numbers into it, I don't want it to be like offset. If I started at 42, then I know what the real answer is. Let's start at 0. And then what I could do is I could add 1 into sum, right? Add 1 into sum. 1. Now it holds 1. And then I'll add 2 into sum. So now it holds 3, right? Then I'll add 3 into sum. Now it holds 6. You see if I did that a bunch of times, then it would eventually hold the sum from 1 to 10 or 1 to 100 even. So that's kind of what I'd like to do, all right? The way to get the number to add in, starting it at 0, is let's just use a second variable. Let's use a second variable to keep track of what we're adding. All right? So like we'll use like a add variable or something. Give it some sort of name. Like the first number I want to add in to sum is 1. bring it in there. Now sum is 0 plus 1, so 1. And then make 2 add 2, something like that, right? And then I'll add the 2 in to sum, so 1 plus 2 is now 3, and just keeps on building up the answer. Yeah? And then once it's 3, we can add the 3 in. 3 plus 3, so now it's 6. Make it 4. Then add the 4 in, now it's 10. And eventually, right, we'll get at the final answer, which I think is 55. Don't quote me on that. We'll find out. But yeah, this is kind of what we're doing. Add 1 into sum, then add 2 into sum, all the way to add 10 into sum. And these just scream loop, don't they? This is very repetitive. These ideas and these bullets, right? These bullets are repetitive. Aha, so that should just be screaming loop in your brain, okay? And that's how we're going to do it. So we're going to turn this idea of like add 1, then add 2, then add 3, 4, 5, all the way to 10 into the sum variable. We're going to turn that into a loop, something that we can repeat, right? So it's got to be the same code, but like the first time it adds 1, the second time it adds 2, and the magic is going to come from this to add variable. Because we're going to like make it bigger every time, we can just keep on adding whatever is in that variable into sum. And so that's something that we can repeat, okay? And we'll eventually like print out sum after we finish. So yeah, let me give you this code. Let's write it, and I'll explain it in more depth later. Okay. So I don't know, file new. When the green flag is clicked, what do I want to do? Well, first of all, I need 2 variables. I need a sum variable, and I need a variable to know which number I'm trying to add into sum right now. So let's call that to add. All right. So sum and to add, 2 places. 2 boxes that I need. Let's rename this default one. That can be my sum variable. I'll make a new variable too. I'll be like to underscore add. All right, and we can check them. We can check them both to show them. So at the start of the program, we'd like to start sum at 0. So set sum to 0 is the first thing that should happen. And then also the first number that I'd like to put into sum is the number 1. So to add should start at 1. All right. 1. That's how they should start their lives. So every time I run this program, you can see that those variables are being set to those proper initial values. We have initialized them. All right. What else? What else? Yeah, now we're ready to loop. So here's the secret. Here's what's going to go on. So I'm going to use a repeat until loop. And if you think about it, so here, what do I want to repeat is the question. I would like to add into sum. Whatever is in to add right now. So let's do this to the side. So I'd like to set sum to be like whatever it is right now plus to add, like 0 plus 1, or 2 plus 1, 0 plus 1, 1 plus 2, 3 plus 3, keep on building it up, whatever's in there. Change sum by to add, or set sum to itself, its current value, plus to add's current value. Something like that, all right? So I want to do that, and then like that'll make the 0 the 1, and then the next number, right, when I wrap back around, because I want to repeat this code, the next number I want to add into sum is 1 more than what's in net to add right now, isn't it? So like, now I should add 2 in, so I should change to add, let's say, by 1, because that'll make it bigger every time. Do you see how, if I repeated these 2 blocks a bunch of times, watch if I click this chunk of them just once, it'll set sum to sum plus to add, so sum will become 1, and to add is ready to add the next number in, so now to add is 2. It's kind of small. Do you kind of get that idea? And now it's ready for the next round, because if I just repeated this code again, right, then I will have added 2 into sum, because it'll set sum to be what it is, 1 plus 2. And that'll make it 3, and then it changes to add by 1 more, get it ready to add the 3 in. So now sum holds the sum of 1 and 2. To add is the next number I want to put in. So I click this a bunch of times. Boop. Now it's 10. We add the 10 in, change to add 1 more time. Now it's 11. This is the sum from 1 to 10. Does that make sense? This is 55. That is the answer. And we know we're done repeating this stuff when to add is a bigger number than I care to add into sum. All right? So I'd like to repeat these blocks. This is where I'm going with this. I like to repeat the following blocks until to add is bigger than any number that I care about summing. All right. repeat until 2 add is greater, let's say, greater than 10, because that's the number that I wanted to go up to. So like once it gets to 11, I want to add 11 and I want to stop. All right. So if I redo this, boop, you can see, oh sorry, greater than 10, excuse me, greater than 10. Whee. And so if I run this, very quickly it gets the answer always, every time. We can watch it work by stopping, slowing down the program. We can say, wait a second, every time you've run an iteration of the body. Okay, see me using those words. So there's the 2 added in, the 3 about to be added in, the 4, there goes 5, 6, 7's going in, 8, 9, 10 is going in, and now 2 adds 11, and that stops the loop. Okay? Any questions about that? That's a little complicated. This is a program to study for sure. That's why I'm giving you these things. But I think the last thing I wanted to do is like let's show the sum, like print out the sum when we're done, so we can have the Scratch Cat say the answer that he worked so hard on. Say sum for 2 seconds or something, and that should do it. Slowly but surely, computing that answer. I mean, we got rid of this block, of course, in the blink of an eye, but that's how that works. You can watch it work too if you check those things. And 55 is the answer. All right. So this is a great example of kind of how repeat until is super powerful. It's like, all right, I want to stop when this happens, when this is true. Keep going while it's not true. Okay. Any questions about that code? It might just be something to stare at for a while. But yeah, let's take this and go a little bit further. I think this is the code. Let's paste a current screenshot in anyway. So here's the code. Boop. What else do I want to do? Is this the right? Yeah. There's that one. And there's the code. Let me draw a picture of how it's working. Okay. So what are we trying to do here? We start off, right, when the program starts, sum starts at 0. And then to add, the very first number we want to add in is 1. So that's the first thing it says. Right? And we start repeating. Repeat all this stuff until to add is greater than 10. Is to add greater than 10 right now? It's just 1. So no, false. So we will run one iteration of the loop. Right? And it's going to set sum to be sum plus to add. So sum becomes itself plus 2 adds, so 0 plus 1, stored back into sum. There's the 1. All right, it's going to hold 1 now. There it goes. And then we get ready for the next thing to add in. So we're going to change to add by 1, which increments it to 2. Okay, so now to add is 2. And then we wait a second, and we come back to the top, and we check, like, should I still be running the loop? We're going to repeat all this stuff until this is true. Is to add greater than 10 yet? No, it's still 2. 2 is smaller than 10. So that's good. We can continue. Let's do another iteration. So set sum to be itself plus 2 adds. So sum is going to become its current value plus 2 adds. So 1 plus 2, 3. And that's being shoved back into sum. So now that's the sum of 1 and 2. See how it's building up the answer slowly but surely? Then we add 1 to 2 add, making it 3. That's the next number we want to bring in. And so that's what's going to be repeated. Okay. And now we just come back to the top. We haven't finished the loop yet. We're not sure. So is to add greater than 10? No, it's only 3. So we will run the body again. Set sum to be sum plus 2 add. So sum becomes itself plus 2 add. 3 plus 3 is 6, being stored back into sum. Incrementing 2 add. 2 add is still smaller than 10. So you bring it in. 10, make it 5. And I think you kind of get the idea. Let's get to the end of the matter. So let's say we're at 45, we get to like that, and like 2 add is 10. And we wrap back around one more time. Right? So go back. If 2 add is 10 right now, is 10 strictly greater than 10? It is not. So it's false one last time. And so then we run the body one more time. So sum equals sum plus 2 add. So, all right, sum becomes itself plus 2 add. So 45 plus 10 is 55. Change to add by 1, 11. Wait a second. Then you always come back to check your condition to see if you can do it again. And finally, we check, is the current value of 2 add greater greater than 10? Yes, it is. So that means we're done with the loop because we're only repeating this stuff until this is true. It's finally true. We are done. We skip the rest of it, and then we go down to the rest of our code. So we say the right answer for 2 seconds, and that's why we print 55, and that's why 2 add is 11 at the end when you look at it. That's what stopped it. That was the last. We don't want to add in 11, so that's why we stopped. Okay. So that is the secret, and that's what we notice. So we stop. We want to stop when 2 add is greater than 10, and that's kind of the condition that we figured out here. Okay? Any questions about this code? So I'm going to have you try something similar yourself for a second. All right. If you're happy with it, here is my new problem for you. So here's the old code. Here's the old code. Take it, make it if you haven't already. Instead of summing up all the numbers from 1 to 10, try to change this code around to sum up all the odd numbers from 1 to 25. Okay. What we'll have to change. See if you can figure it out. Help each other. So I'll give you a few minutes to try this. And do yell at me if you have any questions. See if you can change it around. See if you can figure out the right answer. It should be very similar to this code, but it's not exactly, right? It's not 1 plus 2 plus 3. It's like 1 straight to 3. All right, my timer is about to go off. Were there any questions about this? Did we get it? We don't actually have to move around anything. We just have to like change some numbers around. Anybody find what needs to change? No, or we're just too shy. So the very first number we want to like add in, right, is 1. That's correct. Like 2 add should start at 1. And then what we're doing right now is changing it by 1. So the next number we add in is 2. That's not good enough. The next number we should add in is 3, right? So there's something wrong with this line. How can we fix it? Like I want it to become 3 next. That should be the next number add in. So how would I How did I fix this guy? Remember that changing means increment. Yeah, let's change it to 2. Good. So if it was 2, then you see, like, it would add in the 1, then the 3. They get ready to add in the 3 next, then the 5 after that, because now we're adding 2 each time. 5, 7, all the way to, like, eventually it'll get to 25, right? It'll get to 25 if we let it, right? So it's going to actually stop a little early because of this repeat until, isn't it? It's going to stop once 2add is greater than 10. We want it to stop, like, we want to add in the 25, we want to let it get to 27 even, right? And that's when it stops. So how would I change this to, like, stop it later? Because we want to stop, we want to go further than 10, don't we? How could I change that condition? Because right now it'll stop when it's like 11. We want it to stop when it's, what, 27? So yeah, what's true? Like, we want a true statement still when it's 25, but a false statement when it's 27. So what's a comparison we can make that's true, or sorry, that's false when it's 25 and true when it's 27? Well, it's always going to be in terms of your ending value. So, like, if I wanted to go to 25, just, like, stop once it gets bigger than 25, because that's what I'm incrementing, okay? You guys have to tell me if you don't understand. Either you're shy or you don't understand. I can't tell the difference, okay? So please let me know if this is confusing, and I will try to do better, all right? So that's what needs to change, all right? That'll keep going up to 27, and that's going to stop it, right? Because it'll change by, it'll add in the 25 one last time. We get the right answer, and then we go up one more time to 27, and that is now a true statement. 2add has become bigger, and we don't want to add in 27. It'll stop the loop, okay? That's how that works. And did I already save this program? Here's the old one. And then if we just change this quickly to 25 to, apparently, if I get rid of the weight, the right answer is 169, which is 13 squared. I told you it was going to be a perfect square. Cool. So, yeah, that's how that works, and that's what would need to change. All right? Does that make enough sense? Okay, so I just have a bunch of cool examples to practice what we've been learning. So we have loops as well as our conditionals, right? Our things that have if. So we have our if then else and our just normal if. Those go down one side or another. It runs code if something's true. Potentially something else if it's false. All right. So let's remember that. I have a silly example that involves Halloween. So it's almost Halloween. Eventually. So yeah, I'm going to make a program about ghosts. All right, so here's what we're going to do. We're going to ask the user a question. We're going to ask them if they believe in ghosts or not. And what we'll do is, based on their answer, we will either, like, the ghost will be summoned. We'll have some ghosts, like, waiting in the wings. They will be summoned and show themselves. But if the user does not believe in ghosts, we're going to keep the ghosts hidden. Okay, so there's going to be some extra sprites that are scary, and we'll show them to the user only if they are a believer. Okay, so that'll be the idea. So yeah, let's set the scene at least, and then we'll talk about how to program it. So new file. I guess it can be the scratch cat. That's the one that we're asking. Like, either the scratch cat believes in ghosts or not. He's the one asking the question. Let's have a scary backdrop. I think there should be woods. Yeah, there we go. This is exactly where ghosts would appear, right? And then let's add some ghosts. Let's add 3 ghosts. I think there are a couple that are here. A bat is kind of scary. That could be one ghost. I think there's an actual ghost. Yeah, I could type it in the search bar, but I'm looking for other scary things that I can't remember what their names are. I think there's like a skeleton. I think if I scroll down, I would find it. But like, that can be our 3rd scary thing. Okay, so these guys. We got a bat, we got a ghost, and a skeleton. Those could be our scary ghosts for the day. Okay, So yeah, that's the scene for the program, and now we have to like code up what we want to happen. So at the start, we want to ask the user if they believe in ghosts, and we'll save that somewhere. I think what we'll do is we're going to make a variable, a very long named variable. I'll call it should show ghosts. It's going to be a variable that holds and keeps track of whether or not the ghost should appear. Should start out like 0 or something, because like we want to hide them, and like if it becomes 1, 1 is like true, and they'll show themselves. So that's kind of what our question to the user will change, and we'll have the ghost looking at this variable's value forever in a loop. And if that variable ever changes to a 1, they'll know to show themselves. Otherwise, if it stays 0, they'll keep hidden. Okay, so that's kind of what's going to go on. We'll just like have the ghost watch that variable. Second it changes, they will be summoned. Okay, so that's kind of the idea. Let's try to make it work. So I have a bunch of different sprites right now. What do I want to have happen? When the green flag gets clicked, I would like, first of all, the scratch cat should ask the user, do you believe in ghosts? Okay, so we got our ask block. Do you believe in ghosts? And wait. All right. And then at the start of the program, the ghosts, they should be hidden. All right, we'll deal with that in a second. But we're going to ask, do you believe in ghosts, and wait. And then based on what the user gave us, we'll have an if then else, to set this variable, the should show ghosts variable. All right, it's either a 1 or to a 0, and it should start out as a 0 because that's going to be false for us. Okay, so let me make that as a variable. I'll call it should show ghosts. You can technically have a variable with spaces in the name in Scratch, but you can't in Python, and I'm going to teach you Python later, so that's why I'm doing it this way. So at the very start of the program, should should be 0. That just means like hide. Right, 0 for this variable will mean don't show. 0 means stay hidden for the ghosts. Okay, so there's that one. And then we'll ask the user, do you believe in ghosts, and wait, and we get their answer in this handy dandy answer variable, don't we? And then we'll look at that. We'll check it and see, hey, what was in the answer variable? Was it yes? Did the user type yes, or did they type no? All right, so that is what I can check with the pointy thing. If the answer was yes, then we should change this should show ghost variable, because that's going to be the orchestrator, right? That's going to be what the ghosts are looking for. And if they believe in ghosts, we should set that to a 1 for true, I guess. Set it to 42, set it to whatever you like, but we'll use 0 and 1. Set it to 1. Otherwise, if the answer was not yes, it was like no, or they misspelled it for some reason, let's just like keep it at 0. So technically this else is unnecessary because we started at 0, but it's just good practice. I'll just, maybe as a comment, I can tell you, like, this could have just been an if, right? Technically, this is redundant. Okay, so that's the Scratch Cats program. Does that make enough sense? It's going to set this variable. All right, let's drag it. So should show ghosts right now is 0. If I click on it as the program's running, it's stuck in the ask block right now. Okay, because we have to type something. And so if I type yes, hit enter, this variable now holds a 1. If you can see that, it's very small. But if I typed no or something other than yes, then should show ghost is set to 0. Right? It stays 0. We set it again to 0. So technically we didn't have to do that. And now the ghosts, we need programs for them. What their job is going to be is each ghost, like the bat, the skeleton, the ghost itself, they're going to be watching this variable. Right? So when their program starts, when the green flag gets clicked for them, what they're going to do is they're just going to be constantly checking this variable. Because it might be 0, it might be 1. Who knows how long it's going to take to type and press enter. So they're just going to forever, until the end of time, they're going to watch that variable's value. All right? So here's how this is going to work. So forever, every ghost will be watching this value. All right? If its value becomes a 1, all right, so if, operator for a quality check, if should show ghost ever becomes a 1, then as a ghost, I better show myself, okay? If I'm not already shown, all right? So where's that? That's the show block. So that's that one. Otherwise, if should show ghost was not a 1, that means it must have been 0, because that's the only 2 values we're letting it become. Then we're going to hide all the ghosts, all right? And so forever, as long until the end of time, every nanosecond, the ghosts are going to be watching this variable's value and just like either constantly hiding themselves, like running this block, or constantly showing themselves, forever running that block, right? Depending on the value of that variable, okay? And so that is going to be the program that I want to give to every single one of my ghosty sprites, because it's a different program. Like the programs are at the level of the sprites themselves. So like if I want the bat to do something, I give him some code. If I want the ghost to do something, I give him some code as well. If I want to copy this code, an easy way to do that into another sprite is you hold on to it and you drag it into the other thing. And if you look closely, it kind of wiggles. That's how you can give it that same code. Same for the skeleton. Scroll it down, and it'll wiggle a little bit. You saw that? It's wiggling, wiggle. And that's how you know it's ready to. Like you can let go, and it will have copied the code. So now the ghost, the skeleton, and the bat all have the same code that will run when that green flag gets clicked. All right? So yeah, let's see how it works. Boop. So, bam. Once I start the program, because I set should show ghost to 0, everybody hides themselves. So now they're gone, right? Because each, like you can see that it's highlighted, because this is running forever. It's never stopping. This is the bat's program right now, but the rest are the same. So it's just going off, and it's like continuously checking this variable. It is set to 0 right now because I haven't typed anything. It's staying in 0, and so it's always going to hit the hide part. Does that make sense? It's going to keep going to this one. Keep hiding itself if it's not already hidden, and it is. So there's that. And if we type yes, which will change the value of the should show ghosts variable, it will come back to the top of the loop and be like, oh, it's 1 now, and it's not changing. I'll just be continuously clicking that and showing myself. All right, so now they're shown because I typed yes. All right. But they're still watching the value of the variable. These programs are still running forever. You got to stop it eventually. So, yeah, if I type no, they stay hidden because they're watching the variable's value. It's always 0, and so this is never true, right? It's always false. So it's hidden the else part. Running the body of the else. All right? Yeah, and then let's go back to the Scratch Cats program. It starts off should show ghosts to 0. And the ghosts are looking for that. They're hidden. We ask. And based on the answer, we either set the variable to 1 or to 0. And now they're shown if we typed yes. All right? Are there any questions about how this code works together with the ghost's code to make things happen? It's a fun little example of the day. All right, good. I do have some words to explain what's going on here. So here's kind of the setup. When I enter my answer, right, what's going on under the hood in the program is like that answer variable gets changed. That's the very first thing that happens, right? That's here in the Scratch Cats. Answer variable is always linked to the ask block. So I'm using this to set a different variable, okay? So there's that. And I use that to set that should show ghost variable in my if block, all right? It could just be an if. It didn't have to be an if else, okay? And then every ghost, until the end of time, just keeps on checking, like forever. It's doing all of this, which is itself and if then else. Forever, it's checking this variable's value. The second it's 1, it knows to show itself. Otherwise, it stays hidden. It keeps hiding itself. So this is kind of overkill, because you only should need to show and hide once, but that's how we're doing it right now. It's the easiest way to program. Okay. So it keeps on making that happen. They keep on checking the should show ghosts variable. I would like to just like make it slightly cooler. Let's make the ghosts flicker like they're dead and we can't see them perfectly. So the way to do that is I told you how to make something transparent before. It's called the ghost effect, aptly named for this example. So we can change the ghost effect of the ghosts in their forever loop. Change the ghost effect to, and like what we set the ghost effect to, if you remember that, if I do that, over here, control, what was it? Probably looks, right? It was change something effect or set something effect by whatever. So if I set the ghost effect to 0, it's like perfectly, it's not ghosty at all. It's perfectly opaque. If you set it to 100, it's perfectly transparent. 50 is right in between, so that's set the bat to be slightly see-through. And what we can do is to make them flicker, which looks kind of cool. To make them flicker, I can just like repeatedly, because this is looping, right? I can repeatedly set the ghost effect not to some hard-coded value, because then it'll never change, but to some random value. Right? Change the ghost effect to a random number, and that number is a percentage, right? To a random number between 0 and 100. To a random number. 0 for perfectly seeable, 100 for perfectly hidden. And then there's, is it in operators? Yeah, there's a pick random block, or pick random piece of code. It's a circle thing. So if you click it, every time it produces a new random number between a range. So, I don't know, what should our range be? Maybe like 25 to 85? I have no clue. So this is like 25% transparent to 85% transparent. And if I do this, if I make that happen in my little loop here, do you see how forever it's going to like show or hide the ghost? That's the first thing that happens. And then it's also going to forever, as fast as it can repeat, it's going to change the ghost effect to some different value. And so like very, very quickly, it's going to like oscillate between different random transparencies. Okay. So if I play the game here, this is just the bat right now, but you see what's going on with the bat, which is pretty cool. Yeah. Any questions about why that's working? Like repeatedly running all this code, and like here's some code that gets repeatedly run that keeps on changing how transparent is that particular sprite. That's super cool, I think, at least. So let me give that to everybody else. Let me get rid of their old code and drag in this new code to all of them. There you go. There you go. Now they all have the same thing now. Whee! Now it's happy. So now, if I say no, again they stay hidden. But if I say yes, I believe in ghosts, they are now flickering in and out between the living world and the world of the ghosts. Super fun. All right. Any questions about any of that? I think that is my fancy example of the day. All right, so let me save this so you can have it. And now we have time. I want you to just play around, right? So take that example that I made. I'll give you the code if you haven't made it yourself yet. And I'd like you to just like play around and add something to it, because that's how you learn, right? Make it do something different. Add another ghost. Change different effects. So there's that one. And together, exchange ideas. But yeah, just take some time. You have plenty of time. I'll give you a few minutes to just like play around. Say hi to your neighbors. Work together if you'd like, and like change the code a little bit. Like make the ghost say boo or something when they show themselves. So can you figure out where to do that? See if you can make that work. But yeah, just try to make something cool and different. Change it in some small way. That will really help you learn it, I think. And I am, of course, here to help if you have an idea of what you want to do, but you're not sure how. I can help with that. Make sure you did attendance, too. I think I haven't stopped that yet, but I will. I will after this, if I remember. Yeah, maybe you can like play that sound like of the cat hissing at the ghosts and scaring them away. connect your particular computer to the display so you can show off what you did. Yeah, I hope that was useful time to play around and try stuff. Were there any questions that came up as we were trying stuff? This forever block? Because honestly, the best way to show you what's wrong is to get rid of it. So code that is not in a loop does not repeat. And so if I run this code has already this code has already run. Okay, so it's like at the very start of the program, should show ghost gets set to 0, and this runs once because it's not in a loop anymore. And so it's like, all right, should show ghost is 0, so I'll hit the hide block. It hides the ghost, and then it sets the ghost effect. It's hidden, so it doesn't really matter. And if I type yes, it was the bat that I changed. Notice that the bat is not doing anything anymore because this code that shows and hides is not repeatedly looking at the new value of the variable. See that? Just like, all right, I ran it once, it was 0. When I looked at it, I'm done. Does that make sense? Yes, that's what I want to. I can undo. I just got to do it again. So that's why I want to watch the variable's value in a forever loop, because now whenever it changes, like who knows how long the user is going to take to type yes and hit enter, whenever it's going to be ready for it and constantly checking it. Yeah, that's a good question. All right, I think I saved that one. So yeah, I have just one last example for the day. I'd like to teach you how to make a little game. All right, let's talk about platformer games. So, like Super Mario, for example, is a platformer game, and the reason that it's called that is because like you can scroll left or right, and then you can jump on the little platforms. That's apparently why it's called a platformer game. All right, so let's make one of those ourselves. All right, so we need to make a program that lets us move horizontally, and then usually you should be able to jump. So we'll do that too. All right, so let's make that program. All right, so moving horizontally, jumping. And like, let's have it interact with stuff. So let's do it. All right. So let's make a new program. This is very exciting. So yeah, let's say like the scratch cat is somewhere. To make him move, it can be called scratch cat. To make him move left and right, there are blocks for that. So kind of what we want to do is use our key events. All right, you remember like when the space key is pressed, that's a thing. We want to do stuff when like the left arrow is pressed, right? Make him move left. We want to do something when the right arrow is pressed, make him move right. Does that make sense? That's what we'd like to do. To move horizontally, all that you have to do, because you have a coordinate system, right? You have a coordinate system, like here's your sprite right here. To move horizontally, it's just like changing the x value. I press a left or right key, we should like go and change our x direction. If it's the left key, change your x to be more negative. And then you press the right arrow, change your x location of your sprite to be more positive, because that'll put you over on the right side of the coordinates. Right? So that'll be that one. Left and right make enough sense, I hope. And you have this here. You have change x by blocks. So when we press the left arrow, I want to change x by -10, right? Smaller x, left side, left x direction. Right arrow should make the x become more positive. Like the x is -33 right now. If I press the left arrow, now it's -43. If I press the right arrow, now it's back to -33, 23. And you can hold them in. Whee! Now he's moving left and right. And if you want him to move faster every time you press something, you can just make him move more. Fires. Now it's like 20 and -20, so now if I hold it in, like he's moving a bit faster. It's up to you though. Does that make sense? It's just a coordinate system underneath everything, so like you can affect that. That's pretty cool. So that's left and right. Whee! And then we should also do up and down, right? So we should do not up and down, but like jumping. So if left and right was the x direction, jumping and falling Y direction, yeah. So when we jump, we should increase our Y. and then as we're falling, we should be decreasing our y, okay? So that's what we'll do. So let's do it like this. Like here is the scratch cat, and let's do space for jump. That's like a common jump key, right? So when the space key is pressed, here's what I'll do. I will like warp the scratch cat up by a lot. Like the animation will look like he jumps so fast, like he touches the sky. So I'll increase this the y value by a ton, maybe like 100 or something. Let's do that. So when you press space, the y should be changed by something positive. That's something large. 150 maybe, I'm not sure. Let's try that. So now when I press space, boop, he jumps. Maybe even more, I don't know, 175. Boop, he jumps. And so like he warps up there. We would also like him to fall. That would be nice too. So like when you press space, he should like warp up there and then also glide down to the floor. Alright, so we want to produce animation. And if you remember the code that we did earlier that like made the scratch cat just like bounce around on the screen, it was a loop that just moved him a little bit every time it moved around his body. Remember that? Moved 10 steps and repeated that a bunch of times. That will give us animation here. So it's like we'll bring him down slowly to the ground with a loop and moving a little bit every time. Okay, that's going to produce animation for us. So this will be easier if I make this 180. So let's make it 180. So let's warp up there, and then we want him to fall back down 180 as well. Okay, that's the goal. So here's what I'd like to do. I'd like to change his y by a little every time, like maybe -10 every time. And like click this a bunch of times very fast, and that will produce animation. So we'll do that in a loop. So I'll repeat. How many times do I need to repeat this to bring him down 180? If I'm going -10 at a time, I need to do it 18 times. Right? That'll bring him right back down to where he started. Or, though, if you can hold in left and right, he'll like fall and move left and right at the same time. So that works too. That's going to be the name of the game here. Boop. Oops, what have I done wrong? Oh, sorry, this was set y. I need to be change y. Excuse me. Let's see here. Change y by -10. So now, let's move him back to a nice starting position. Move left and right. Bounce. Whee! And then he's falling back down. -10 bits at a time, 10 units, and just like it's clicking this 18 times fast, and that's producing our animation. Okay, so now we got left and right, and like you can move left and right as you're falling as well. Like those events, they can fire at the same time. It's pretty cool. But yeah, that's the beginnings of a game, isn't it? Any questions about that so far? Does that make enough sense? I like it. So let's give some more real meaning to this. Let's make a real game now. Let's do a silly underwater game. Let's be like the scratch cat. Obviously, as a cat, he likes fish. So let's make him be underwater, and he will jump up and like catch fish. Okay, so that's what we'll do. So let's add a backdrop for the ocean. Underwater. There's an underwater 1 backdrop. Perfect. All right. And then we need a fish for him to catch, too. So I'll add a sprite. I'll search for fish. That's a good one. Nemo. And then, yeah, the goal is I'd like the scratch cat to be able to jump up and, like, catch the fish. Okay? That's the goal. Like, when he touches, it's like a coin in Super Mario or something. When he touches the fish, I want him to be able to collect that fish. Okay? And get points for it. So, yeah, now, if we want him to do that, we need, like, a points variable, don't we? We need a points variable to keep track of. So let's make that. Rename points. And, well, now we do need, like, the green flag or something, don't we? Because we want to start out the program where the point starts out cleared out at 0. So, let's do that. And the fish, when the green flag gets clicked, we'll, like, 0 out the points. So that needs to be initialized always. And then we'll just keep on checking, is the scratch cat touching the fish? If so, he'll like collect that fish. Right? That's going to be the goal. So, yeah, every time he touches the fish, we want that fish to be collected, and we get a point for that. Okay? And then we want the fish to like disappear and teleport to somewhere else, and like he can collect them all over again. That'll be the game. Okay. So, I guess what we want to do is we can let the fish do this job. We can let the fish, because I'm on the fish's sprite right now, it's going to need to keep checking, like somebody. So either the scratch cat or the fish, doesn't matter. We'll do it with the fish. Somebody needs to keep track of whether or not the scratch cat is currently touching the fish or not. And that's going to require another infinite forever. I hope that makes sense. Just like forever, keep checking. Is the scratch cat right now? Second, is he touching the fish? And then there's an if block, and there's operators for that. There's it's in sensing. It's like, is it true that this current sprite, it's always from the perspective of this current sprite. So the fish is the fish, because this is the fish's program. Is he touching the scratch cat? Okay, and so right now it's false, because they're far apart. But if this were true, if he's right here, back to here, is the fish touching the scratch cat right now? It gives back true. See that? So that's what we can hook into. Bring him back down, though. Bring back to the fish's program. So forever, keep checking. Hey, is the scratch cat touching the fish? Or is the fish touching the scratch cat? Whenever that's true, we need to get a point, right? So let's change points by 1, I guess. That's the first thing to do. And then we're going to have to like deal with warping the fish somewhere else so like this becomes slightly fun. Okay? But yeah, are there any questions about this so far? So we've got the left, right, and jumping on the scratch cat, with which each of these different kinds of events are covering, right? Does that make enough sense? The falling, just repeated small chunks of falling becomes animated falling. Whee! And then the fish will keep track of the points, start them out at 0, and then also keep checking to see if the scratch cat is touching. And if so, change points by 1, which will keep your mana points. So if I click the green flag to like start it all over, and like now the forever loop is firing, keeps on checking, hey, is the scratch cat touching me? Is that true? If he ever now touches the fish, and he's not right now, if he ever touches the fish, we'll gain some points. Boop. And if you notice, points is not incrementing by 1 right now. It's going by 3. Because, yeah, I don't know how much I've told you about animation rates, but it has to do with frame rates. And so, like, for 3 frames of the animation, apparently the scratch cat is touching the fish. So he's touching it for a while, and the fish notices, like, a bunch of times. It's like, all right, change points by 1. And, like, he's fallen a little bit more, but he's still touching the fish. So give him more points. That's what's happening right now. We need to stop that. We need to make it show so that it's only 1 point every time. Okay. So let's do that. And honestly, that's all going to be solved by doing this last thing. Let's have the fish every time, like the scratch cat gets 1 point, we'll have the fish immediately disappear and teleport somewhere else. All right. So like after we get the points, change points by 1. Let's then hide the fish. Can't be touched while he's hidden, so that's perfect. Hide the fish. That's in looks right. Hide that fish, and then we need to teleport the fish somewhere else. All right. So like if the fish was here, like we want to hide him because we just claimed him, and then we want him to like pop up over here somewhere, or pop up over here somewhere, some random place like along this line, somewhere up here. So I'd like to give the fish a new random x coordinate. Does that make sense? Because that's controlling left and right. I like to give the fish a random x coordinate. Keep the same y. Keep him up here still, but move him left and right. All right, so that's going to be the goal. So set my x coordinate. That's going to be in motion. Set my x coordinate, Mr. Fish, to some random x coordinate, which is down here in operators. Pick a random number between, like, I don't know, that's negative 180 and probably positive 180. That'll work. Negative 180 and positive 180. I got my digits out of order. So that'll work. And then, like, once he's there, we need to, like, I don't know, maybe, like, wait a second, like, have him load or something. Wait a second and then show yourself, Mr. Fish. Wait a second, and then you can show yourself again. So for a second, he's hidden, right? So yeah, every time the scratch cat touches the fish now, what we will do is we'll give him a point. We will hide that fish. We will warp the fish while he's hidden to some random x coordinate. So it'll stay along this line somewhere, but some other random place. Wait a second, stay hidden for a second, that is, and then show yourself at that new place we picked. Okay? There's a lot going on there. Is that a question? Yes. No, it's just because I put him here with my mouse, now it's just stuck there at that same y coordinate. Yeah, good question. So now back, if I click the green flag, we zero out our points, and I jump and eventually hit the fish. I only get 1 point. He stays hidden, and then he teleported to be over there. That's a fun game. There is, well, first of all, does that make enough sense right now? So the scratch cat is doing easy things. He's just moving left and right and jumping. The fish is doing the complicated stuff. He's forever checking, hey, is the scratch cat touching me? If so, do all these things. Give him a point, hide myself, warp while I'm hidden, and like stay hidden for 1 second, and then show myself in that new place. So it's a little bit complicated, but that leads to a slightly interesting game. This could entertain a child for a little while, right? So yeah, that is, and you see that the y coordinate stays the same. It's like whatever I put him at the mouse, like only the x is changing. And so that keeps them along that line up there. Okay? Any questions about that? Because I think there's one last thing that could be wrong, that could go wrong, that I want to fix. It's if I just so happen, like you eventually have to stop the program, right, to start again with the green flag. If I were to stop the program as the fish was hidden for that 1 second, boop. Not only is the scratch cat in a weird spot now, but also, if I ever, like, even if I move him back down to here, the fish will never show itself again, because it's impossible to touch a hidden thing. So now the game, like, we've broken the game in that case, okay? So at the very least, you should always remember to show the fish at the start, just in case that happens, okay? So that'll force him to be shown, and now we can play, all right? And a similar thing you can do for the scratch cat, like start off, maybe when the green flag gets clicked for the scratch cat, you can start him off on the bottom somewhere always to make sure that, like if you stopped him halfway in his fall, like you're not in a weird spot. Okay? So that's something you could look into. Exercise for you guys. All right? Any questions about that? It's a fun little program, and I'm going to give it to you. So if you haven't seen the code from class links yet, like take advantage of that. You can load this yourself. But that's that one, all right? So I think I've explained it all, and yeah, if we are good, I have one last thing to talk about today. I want to give you your next programming assignment. We're on programming assignment 2 now, so this will be due next week, I think, 5th or 6th, yeah. So a week and a day. I would like you, I think, is do something very similar to this, all right? So make your own little platformer game. If you're in the group, of course, that's doing Scratch programs. What I want you to do, make your own little platformer game. You can start with what I gave you, but you have to mix it up, okay? You can't do exactly what I gave. So here are your requirements. Excuse me. So I'd like you to have some kind of character sprite that walks left and right with those arrow keys and jumps with the space key so that you can steal everything I did for that, all right? And then I would like something cool to happen when you touch another sprite or jump into another sprite. All right, just like I had with the fish here. You cannot copy that. You have to pick your own cool thing. And just to make sure it's interesting, I want you to make sure you include at least 2 looping blocks in your program. Anything that's going to loop. So repeat counts, forever counts, repeat until counts. But I need to see at least 2 of those to make sure you're doing interesting things. And yeah, you can use what I gave you as a starting point, but that can't be everything you do. Like change the scenario. Don't make it a cat versus fish. Like do something unique and different. And I will have fun watching what you do, okay? So this time, please upload a video of your program. I want to watch it run. I'd like to see your code visible, and I'd like you to explain it. So I need to hear your voice, okay? Make sure that I can hear your voice explaining your program so that I know that you wrote that code and you understood it, okay? That's what I want. It does not need to be long, just like, it could be 30 seconds. Like, all right, here's my code. Here's my code. Here's it running. Here's what's happening, and like this loop is running whenever the scratch cat touches the fish, and this is what's going on in the body of this if. We're changing the points, hiding him, like stuff that I was explaining. Just kind of be like me, okay? So that's how that works, and yeah, that's what I want to see. So come up with a cool scenario. I've seen a lot of cool ones from students in the past, so I'm excited to see what you guys come up with. And please record a video of you showing off your fancy program. Any questions about that? All right, and if you're one of my students who have programs, then if you're doing the default record assignments, we'll move you on to these chapters, read those ones, and then do these 3 exercises. I think that this one might require a Dr. Racket finally. I think this might be a graphical one. But yeah, do those, and then also you can contact me if you want to do something But just like everybody else, give me a video of your program running and explain your code to me, just as you would expect. That's the assignment descriptions. Any questions about any of that? All right, then. That's all I got for you.